Good day, everyone. We are welcome to ChemExcel Academy Chemistry tutorial platform. Based on the last concluded practicals that was introduced to us on this platform, first and foremost, don't forget to subscribe, share, and like whatsoever that has been given to you from this platform, and also you are being welcomed with various comments from you. Thank you so much. Then during the last class we started with quantitative analysis, which is also known as volumetric analysis. That is the titration between acid and base. And here is the second aspect, the second part of the practical. Of course, it is called qualitative analysis. This is also a likely question which you should be expecting from the incoming exam. Okay, we have C is a simple inorganic salt. Carry out the following tests and record your observation and identify gases involved where necessary. What are we to do? First, add about 10 cm cube of distilled water. In case you don't have distilled water, you can make use of either your tap water or any other source of water. Okay, distilled water to sample C. After all, this is what is going to be given to you as your sample C, or properly labeled for you. It says record your observation and inferences. Divide it into 3 portions. That's why for this aspect we have test, observation, and inference. Okay? We say to the first portion, after you have divided the solution into 3 portions, in the first portion add sodium hydroxide solution in drops, then in excess. Also to the second portion, you add aqueous ammonia in drops, and then in excess. To the third portion, you are to add dilute hydrochloric acid, and then followed by barium chloride solution in drops, and then in excess. Now, we are going to follow this procedure one after the other. The steps one after the other. We start with test. Okay, for test, as far as the first aspect is concerned, the first instruction we have to do, we say C, of course, or you say sample C. Say sample C plus distilled water, liquid. That's the instruction. Sample C plus distilled water. It means we are to add this sample C. You can get a test tube or your boiling tube with you, preferably a test tube. They must have given you this inside either a test tube or boiling tube. Just a spatula of it. Now, this is water. Just add your water. They said the water you are to add is about 10 cm cube. 10 cm cube of water must not be more than this. This is what I'm going to add. 10 cm cube of water cannot be more than this. Cannot be more than this. Then you shake so as to know whether the salt dissolves in water or not. Anytime you are given a salt and you are being asked to add water to it, they want to test for solubility of that salt in water. Either it completely dissolves or partly dissolved in water. And by the time you add your salt to water, it's just like you are adding solute to solvent. Addition of solute to solvent will make solution. As you can now see that this is a solution of the salt. This is salt solution. In fact, this is solution of sample C. This is no longer sample C, but it has become solution C. Now, what do we observe when we add water to the salt? What happened is this. We can see that here the sample C dissolves completely in the water. It dissolves completely in water to give the color. We need to identify the color of the solution form. Is it a colorless or a colored solution? What's the color? We mentioned the color. Is that clear? Having known that, it means sample C dissolves in distilled water to give a blue solution. Of course, everybody can see this is a blue solution. Then we write. It says sample C dissolves completely. Dissolves completely in distilled water. To give a blue solution. Then we have to come to the inference. The inference is what kind of salt is sample C. That means we say sample C. We say sample C is a soluble salt. Now, having done this, we move to the next phase of instruction. The next phase of instruction says, record your observation and inferences. Of course, we have recorded our observation, and then this is the inference. The next thing is, we say, to the first portion of the solution. That's the meaning of to the first portion. When we talk about the first portion, say to the first portion simply means we divide this into, we count the number of instructions. This is 1, this is 2, this is 3. You can just take a portion like this, just a portion from it. Make sure you are dealing with clean test tube. You add just a portion. This is okay. We are to add sodium hydroxide. We can now say, here, since we have dissolved sample C in water, it's no longer going to be sample C again. It's going to be solution C. It's now going to be recorded as solution C. Solution C in aqueous form plus sodium hydroxide. Sodium hydroxide, you put it there in aqueous form. Sodium hydroxide in drops, and then in excess. We are going to record 2 observations here. First, when we add sodium hydroxide, because this sodium hydroxide, when we add add sodium hydroxide in drops, we record our observation. Then in excess, we record our observation. At the same time, we come here and show our inferences on the two occasions. Let's look at it in drop. It's just like you are having a drop of water. You can see in drop, just one more drop. That's it. This in drop. You can see what we have in drop. In drop, you can see that there is a kind of colloid being formed inside that solution, like a color. The thing is not clear, and just like a cloud. It's just forming like a cloud, and by the time you check the body of the test tube, it's be as if there is a kind of oil around the test tube. Oil, as if it is oily, as if you are making use of grease. Those colorless grease we do use in cleaning our body. Okay, if we are looking at it, we record this as blue gelatinous. See, blue gelatinous. Okay, you say pale blue rather, because it's not deep, it's pale blue. Say pale blue gelatinous. Pale blue gelatinous. Pale blue gelatinous precipitate. Precipitate form. That's going to be the result for in drops. You can see it's pale blue gelatinous precipitate. Gelatinous, just looking as oily. Making the body of the test tube to look like oil is oily, like making use of grease. Okay, here it says Cu2 plus present. That is in drops. Now in excess, what do we have? Let's now add in excess. Okay, what happened to the precipitate? When you get it in excess, say the precipitate, this precipitate forms more. Precipitate, it does not dissolve. The precipitate does not dissolve. It does not give a clear solution. We say precipitate, insoluble. This does not dissolve. Precipitate, insoluble. Precipitate, insoluble in excess of sodium hydroxide. Say Cu2 plus. Don't forget capital letter C, small letter U. Cu2 plus present as usual. We are done with sodium hydroxide. Now we are moving to another solution. This solution is called aqueous ammonia. Of course, that's the second step. He said to the second portion, we have to add aqueous ammonia. Now say solution C as usual. Solution C plus aqueous ammonia. plus aqueous ammonia. Aqueous ammonia is also known as ammonium hydroxide solution. Either of the two is either they write plus aqueous ammonia or ammonium hydroxide solution. It's still the same thing, still the same reagents we are being asked to add. Okay? Because we are okay. You have aqueous ammonia here. Aqueous ammonia in drops, and then in excess, and then in excess. Okay, we come here, solution, we pick just small portion from it. In some cases, they can say 2 cm cube. You can see. You don't need to bother yourself. Once you get this, you've already achieved your 2 cm cube. They say small portion, use it. Now, we are moving to aqueous ammonia. Aqueous ammonia in drops. What do we have? Let's see that. In drops. You can see drops. As usual, we have pale blue. Pale blue. As usual, you can see we have pale blue. We have pale blue gelatinous precipitate. Yes, pale blue gelatinous precipitate. For Cu 2 plus precipitate. Okay, that's in drop. In drops we have this. You can see the pale blue, like that of ammonia. Sorry, like that of sodium hydroxide solution. But now we want to add in excess of aqueous ammonia. Let's see what happens. This is in excess of aqueous ammonia. You can see what happens. In excess. This is in excess of aqueous ammonia. You can see that the first result is not the same thing when we add in drop. It's not the same thing as what we have when we add in excess. Then we come here. How are we going to record this? You can see that the pale has dissolved into this to give us a solution. We say we say precipitate dissolve. We are referring to this precipitate. We say precipitate dissolve. Precipitate dissolve. Dissolve to give a deep blue solution. To give a deep blue solution. Then here, okay, here we are Cu 2 plus confirmed. Anytime we make use of sodium hydroxide and ammonia, we are trying to test for cations. And what are the cations? Those cations, they are Al3 plus, Zn2 plus, PB 2 plus, CA 2 plus, and for the colored areas, they include Cu 2 plus, Fe 2 plus, Fe 3 plus, and so on and so forth. These are the major. Once we make use of sodium hydroxide, we use it to carry out a test. We make use of aqueous ammonia or ammonium hydroxide solution in order to confirm what we have tested with sodium hydroxide. That is when we are dealing with metallic ion or cation. Now we are done with one aspect, which is test for cation. We now want to test for anions. How do we do that? What are the reagents we make use of? We make use of these two reagents. Always take note of the two reagents. What are the two reagents? Barium chloride and dilute hydrochloric acid. They are very, very important. We must take note of them. Barium chloride and dilute hydrochloric acid. Now, before I proceed, the function of hydrochloric acid, you know that our salt is dissolved in a neutral solution, which is water. Now, dissolving or adding dilute hydrochloric acid into that salt solution make it to become acidic. I mean, make it to provide acid.
3.
All right. Now, we want to move to the third portion aspect. I mean, the fourth instruction. Say solution C. Solution C plus dilute hydrochloric acid, then followed by say plus, maybe we should write it in full, hydrochloric acid plus, I say followed by barium chloride. Barium chloride solution in drops, and then in excess. Okay. All right. We have our solution C. Just pick a portion from there. Okay. We had because we want to test for anion. Then we make use of barium chloride and hydrochloric acid. Hydrochloric acid comes first, because we just want to change the medium from neutral medium to acidic medium. That's what is going to do. If you add hydrochloric acid to it, what do you have? You can see there is nothing new that happened to the solution. The solution still maintains the way it is. It's just that the solution suddenly turns acidic. It becomes acidic. It's just that the acid try to provide a reaction. For this, plus dilute hydrochloric acid, since there is nothing we can see, you see no visible reaction. Since there is no visible reaction, we can't give any information on the inference. We can only make inference based on what we see. Okay? Now, having done that, we can add our barium chloride now in drop and then in excess. We want to test for the anions present here. In drops. You can see what you can see. Oh. In drops. Okay. Sorry. Here we have two. Okay. See from the beginning. Now we have we have the solution C. Just as small as this can give us what we need. Then we add dilute hydrochloric acid. You can see there is nothing visible about it. It's a no visible reaction. No visible reaction. Of course, our inference is dash. Then we pick barium chloride. We put it in drop, add in drop. It's like a drop of water. See a drop. See what you have. Something looking cloudy, white in color. You see, this is white precipitate formed. White precipitate formed. That is in drop. Then what are the anions that are likely present in this drop form? We have CO3 2 minus. We can have CO3 2 minus. We can also have SO3 2 minus. SO3 2 minus and SO4 2 minus may be present. May be present. We are not sure yet until we carry out that of in excess. Let's now see what happened in excess of barium chloride. You can see. This excess, you can see, we still have our white precipitate remain. See that you say white precipitate insoluble in excess of barium chloride or white precipitate remain. Any of the two is acceptable. White precipitate, or we say precipitate insoluble. Then let us repeat it again. Precipitate insoluble. Precipitate. Insoluble. Then you can now say, and once it is insoluble like this, it is SO4. SO4 minus SO4 minus present. That brings us to the end of this practical aspects for this incoming examination. Thank you. Have a great time. Don't forget to subscribe to my channel, like, and make comments. Thank you.